Welcome back to Let's Code. Today we're upgrading a game to Bevy 0.10. Now I've upgraded quite a few games at this point with my Rust Adventure workshops and also just games that I've made. So here's one example of that. Before I get into everything, I think that there is some kind of issue with Winit specifically, that is dumping a ton of stack trace or backtrace looking output into my console. I've opened an issue for that. It seems like other people are seeing it too, but it doesn't seem to be affecting any actual game behavior. So I'm just going to live with it for now. That said, this is a block breaker game. It's got a couple of buttons and a menu. You start the new game, the ball goes up, it hits the blocks, the particles hit whenever it hits anything else. This is Bevy Rapier 2D, Bevy Hanabi. It also uses IS loopless, which is going to be really interesting for the upgrade because Stageless is now in. So let's get rid of that and let's take a look at what this project is using and how we're going to upgrade it. We've got a couple of crates that are going to be fairly easy or basically non-upgrades. Like Bevy Asset Loader, we aren't going to have to change anything to actually get this to go from 0.14 to 0.15. Bevy Prototype Leon has some minor changes. IS Loopless is deprecated from this point forward because Stageless has now actually made it into Bevy, so that's going to be a major change for us. Kayak UI doesn't have a version for Bevy 0.10 yet, so we're actually going to drop it for today, and then we might go back to it later. And Bevy Rapier 2D doesn't really have any changes that we need to execute on this project, but Bevy Hanabi does have some minor changes, minor API changes. So most of our changes are going to be IS Loopless, removing that, starting to use Stageless for our on-enter, on-exit, on-update systems, as well as our systems that run in different states. So I went ahead and removed Kayak UI. I got this new menu here. There is a button on the left and a button on the right. You hit the button on the right, the game starts. You hit the button on the left, the game exits. This encompassed about 200 lines of UI code. Bevy UI now uses Taffy v0.3, I believe it is in this release. And the UI code is just getting better in every release, even if it's just a little bit. So we've got two systems for buttons and one system for handling the state change. In this game, we have a couple of different states. We have being in the menu, playing, and paused. And that changing controls whether the menu shows up or not. So game UI is actually pretty simple. It's a node bundle that fills the entire screen. Let me just run this so we have a little visual here. So this node bundle is filling up the entire screen. It's 100% width, 100% height, and it's got a padding of about 10 pixels. So that's how we get this little border between these buttons and the outside. Inside of that rectangle, we have both of the buttons. Both of the buttons are squares at 250 pixels. They're laid out using flex, which is how we get the text in the center here. We load in a font, and that's about it. It's not super interesting. We attach a couple components. So we attach a component for the new game button and a component for the exit game button, as well as a component for the menu itself. That's because we have a different system to handle the new game button as well as the exit game button. These are both basically the exact same system, which is it feels a little bit weird to have two systems for two buttons that basically do the same thing, but I'm more or less okay with it for now. You can see we're inserting the game state playing resource for IS Loopless to pick up and then transition into actually playing the game when we click the new game button. And then when we click the exit button, we send the app exit as an event, and Bevy will actually just close the app for us. And finally, the way that we get this menu to show up and disappear whenever I click new game like this is whenever the game state changes, we grab the current game state and we grab the menu component that we saw earlier along with the visibility for that entity, and we set that visibility to either visible or invisible. About 200 lines of code total. Very similar to what you would see if you went and looked at the Bevy UI button example or something like that. And here we have the full upgraded to Bevy 0.10 game. It looks much the same. It doesn't do anything really different. You can see that Bevy Hanabi with the particles is working, Bevy Rapier with the collisions is working, as well as anything else that we actually have running. So we can lose the game here and I'll click out. Our UI code really didn't have to change at all. The only thing I added was this optional gap property that is now available to us in Bevy 0.10. And if I bring the game back up, you can see that there's a gap now between these two buttons, and that's what this gap is doing for us. And of course, this game is in the Blockbreaker repo, so we can go to the Blockbreaker repo in Rust Adventure and take a look at what actually changed here. So first off, we upgraded basically everything and we removed IS Loopless completely. I think Split will actually be better for this video. So on the left-hand side, we have all the dependencies we got rid of, as well as on the right, all of what we basically upgraded to. So Bevy Asset Loader, 0.15, Bevy Prototype Leon 0.8, Bevy Rapier bumped 2 minor versions to 21, and Bevy Hanabi has a 0.6.1 release. Some of the simpler changes were around Bevy Prototype Leon. So on the left-hand side, we have a geometry builder where we build up a shape, and then we set some draw modes and stuff like that alongside a transform. In the updated APIs, there's a shape bundle that takes the geometry builder as a path. The transform goes into that bundle, and then fill and stroke are extra components. So as of Bevy 0.9, I think this was available, you can now add components as a tuple. So the shape bundle, as well as the fill, as well as the stroke, are all being added to this entity, which is really nice. I like this move towards sort of tuples as groups of stuff that you can add. This is also going to be true in add systems in a little bit. We were using game state, remember, to transition between menu, playing, and a theoretical paused state. So we did have to add this new states derive as well as a default value. And we'll see why the default value is necessary in a second, but we can use this little, attribute macro, if you want to call it that, to define which state or which variant of the enum in our game state is the default one. The WGPU settings options changed a little bit for Bevy Hanabi, but this is effectively the same thing. We're just modifying the render plugin now rather than setting the settings as options as a resource. And right here is why we need to actually have states and default on game state. So previously, this was an IS loopless thing. We had add loopless state here on the left, and we got to bootstrap it with some starting state, and that was that. In the actual Bevy version in 0.10, we get add state, and it takes a type argument of the state to add. So that state needs to have a default value for Bevy to know what to instantiate it to. Alongside some more of the IES loopless changes, we used to have add system set and add enter system as functions that we could use to add more systems. And I think this actually cleaned up quite a bit. In the actual version of Stageless that got merged into the Bevy repo, we now have add system and add systems. Again, this takes a tuple of all of the systems we want to add, and then we can apply in set with this on update for the game state that we want to run these in. So whenever the game state is in playing, we're going to run all of these systems. Similarly, we have add system, and we can use in schedule, which is slightly different than in set, for on enter and on exit. So we still get our add enter system and add exit system. We just now use the actual system that we're going to run, or the group of systems. Then we call in schedule on that system, and we specify the schedule. If I open this up a little bit, we see some of the changes for Bevy Hanabi. Bevy Hanabi now didn't change very much. It just changed a couple of the components that we want to use to realize the same effect. So we still have the init functions, we still have the render functions. We just now have more split up components for defining where those particles go and how they evolve over time. Here for the enter system and exit system for starting and stopping the timer for how long the game has been running, we again have IES loopless changes. So we got rid of add enter system and add exit system, but we can again use in schedule to do on enter and on exit for any particular game state. Similarly, in the UI file, we still have add startup system, but now we're using the new add systems, which makes this, or adding a bunch of systems, in my opinion, quite a bit cleaner. And I could like it quite a bit. Now, we could change some of these systems to only run in a certain game state, but I chose to just not do that because it's not super important for me for this game. The way we query and modify game states in our systems has changed as well a little bit. So on the left-hand side in IES loopless, we had commands insert resource with a next state enum, or next state struct, and then we passed in the sort of next state for the game state, the variant that we want. Now we have to query for the next state mutable resource, and then we can set it to whatever we want. So very similar, but not a command, just a set now. Similarly, if we want to access the current state, instead of looking for next state like we do up here, we can look for the state resource. And we can match on that just the same way we did before to see whatever state we're in. And the final change is, I'm not sure why this happened, but we now have visible, hidden, and visible for visibility instead of visible and invisible. So the changes weren't that bad, honestly. This is only about 1,200 lines of code total inside of the source directory. So it's not a terribly large game, but it is a game that uses IES loopless and some of the new stageless features in a couple of different files and relies upon them quite heavily, actually. So to round it out, we've got this game, we've got the UI. Whenever we click start, the visibility on the menu changes, and then we get to play our game, which is Bevy Hanabi with further particles, Bevy Rapier 2D for the actual collisions. I have a couple bugs here to fix still that are unrelated to the upgrade, such as this pill being vertical instead of horizontal. But that's it for today. I don't think the upgrades are that bad for Stageless, even though Stageless was fairly a large change. And it's always nice to see that the crates in the ecosystem update fairly quickly as well. So that's it for today. I will see you in the next video. And until then, have a great rest of your day.